Welcome to Rges Pre-Algebra. This is lesson 29A. We're going to be discussing 8.16 and 8.20 in your book for the new concepts. 8.16 will be about triangles and 8.20 about perimeter. So we're talking about triangles and perimeter. Now you should have taken and mailed in your test, which would be test 5 on chapters 5 and 6. So make sure that if you have not done that, you do it at the earliest possible convenience. Make sure you discuss this with your parents. I am checking in with your parents on your how well you're keeping up with the class. Now remember, we have switched gears here. We're not looking at this as though we would be back in class in a couple of weeks. We know now that we will be out of class for the whole semester, which is fine because we can still continue teaching through the YouTube videos. But you do need to have the responsibility to keep up in your assignments. And rather than just having tests, from now on, I'm going to have 2 quizzes and a test for each chapter. And that way, we'll have more grades and we'll be able to check up on you a little bit more because we know that this will be, like I say, till the end of the semester. Now, let's go ahead and start with this devotion. I would like to turn your attention to this wonderful promise from the scripture in 2 Thessalonians 3:16, and he says, "May the Lord of peace himself give you his peace at all times and in every situation." And the encouragement here is that the Lord makes his own peace available to us as we turn our hearts to him and ask for it. He is loving, he is kind, he is gracious, he is merciful, he is always there. In fact, the scripture says, the eyes of the Lord run to and fro throughout the whole earth, looking for those whose hearts are poised towards him or turned towards him. So turn your heart to the Lord and he'll fill you with his peace, his own peace that passes all understanding. It says at all times this is available to us. Even the times in which we live right now, and in every situation, both personally and culturally, or as a nation, or as all the global crisis that we're facing with this pandemic, it doesn't matter. In everything, he makes available to us his peace. So if your heart is lacking in peace, or agitated, or concerned, or full of fear, all you have to do is stop, pause, and turn your heart to him. Ask him for his grace. Ask him for his mercy. Ask him for his peace. Ask him for increased faith. This can be a time that you can grow in your faith and confidence that God has you and he is in control. So let that be your prayer today. Now we'll go ahead and do our answers to our problems. The ones we need to review are 8.7, 1 through 16, 8.8, 1 through 14, 8.9, 1 through 7, and the sharpening skills 1 through 10 all. So if you don't already have your homework assignments, please pause and get those. Remember, it is up to you as the student to keep up on your work and actually be doing it so that you can check it. It's no good just to kind of follow along and listen. You have to check your work and make sure that you're doing it on your own before you come to listen to this tape. All right, go get your work if you need to, put it on pause, and we'll meet you here in just a second. Okay, I'm going to be giving you the answers orally unless I feel there's a need to draw it on the board. What point is the center of the circle? The answer is O. What are the drawn chords of the circle? That just means that any lines that have both endpoints on the circle, they would be DE, line segment DE, and line segment AC. Now recall that if you said ED instead of DE, that's perfectly fine. Okay. What are the drawn radii of the circle? Radii is the plural of radius, and that means any line segment that comes from the center outward. So OA, OC, and OB are all radii. What is the drawn diameter of the circle? It would have to go through the center of the circle, one line segment from the edge of the circle to the other edge of the circle, going through the center. That's a diameter. And so the only diameter we have here is line segment AC. How many diameters does the circle actually have? Not how many are drawn, that would be only one, but how many diameters exist, and that would be an infinite number. If you have a circle, you have a center, you could go there, you could go there, you could go there, you could go there, all the way around, go through the center, as many times as you can draw. You can get a new diameter. The radius is what fractional part of the diameter. Okay, so if the diameter is that, the radius, let's get another color here so you can see it easily, would be from the center out, and so it would be a radius is 1/2 the diameter. Why is ED not diameter? Well, ED is something on the picture that is like this. It does not go through the center, so it's a chord, but not a diameter. A diameter must go through the center. What is the ratio that shows the relationship of the length of the diameter to the radius? Coming back to this idea, the diameter to the radius is 2 to 1. Means the diameter is twice as large as the radius. Number 9, find the length of the diameter of a circle if the radius. Okay, they're giving us the radius is 1/2. So to do these, all you need to do is double. Number 9, 10 inches. Number 10, 4 feet. Number 11, 15 inches. Number 12, the answer is 18 centimeters. For the next group, it says find the length of the radius of a circle if the diameter is such and such. So we're giving the diameter. To find the radius, we would cut it in half, the number in half. So the number 13 would be 7 feet, number 14, 4 1/2 inches, number 15, 6 yards, and number 16, 2 1/2 meters. For 8.8, it tells you to draw and label circles. Now, you need a compass to do this, and I exhorted you to be able to get a compass so that you can have the practice of drawing a circle and drawing several circles. Now, there's no way to test that part, but we explained how to do it last time. But in the last part of 8.8, it says draw a circle. Number 11 says draw the circle with a 1-inch radius. I'm just going to draw a circle here. It says label the center. So that would be the center O. On the same drawing, it says draw a radius and label it OY. So a radius goes from the center out. The center is already labeled, and this would be Y, this point right out here. Number 13, draw a chord and label it AC. A chord would be anything that does not go through the center and has the endpoints on each side of the circle, where both endpoints are located on the sides of the circle. Okay, so this would be AC, that's a chord, and draw a diameter and label it MN. I want to just any line that would go through the center labeled MN, just like that. So that would be 11 through 14. Let's look at, so that would be on 8.8. On 8.9, to do this first set, you must be able to have a protractor so that you can measure. the angles. We talked about how to do that last time. Your answers should be within 5 degrees. Number 1, 100 degrees. Number 2, 30 degrees. Number 3, 80 degrees. Number 4, 105 degrees. And number 5, 45 degrees. So you're using your protractor to get those answers. It says draw a circle with a 1-inch radius, divide the circle into 3 central angles of 100, 90, and 170. And again, we showed you how to do that last time. That's difficult to check. But if you had any questions about that, 6 and 7, if you struggled with that, check with your parent and see that they can walk you through that. All right? Number of sharpening skills then. We're converting back and forth from radius to diameter. If you've given the radius, you would multiply it by 2 to get the diameter. If you're given the diameter, you would divide it by 2 to get the radius. If they're in a 2-to-1 radius, diameter, of course, being the larger one. All right, so number 1, 18 inches. Number 2, 3.5 inches. Number 3, 5 inches. Number 4, 5.6 inches, number 5, 6.5 inches, and number 6, 6.2 inches. Looking at 7 through 10 to the nearest 5 degrees as you measure it. Number 7 is 155 degrees, number 8, 110 degrees, number 9, 25 degrees, and number 10, 70 degrees. Now, I will be attaching to an email your quiz 21, which will be on lessons 8.1 through 8.9. Okay, quiz. Look in your email, your parents' email. They should have this and be able to print it out for you. Again, closed book, closed note environment, signed by your parent, and stuck in an envelope to be mailed to me. Quiz 21, 8.1 through 8.9. Now let's go on to the new concepts. We're learning how to name different types of triangles. Okay, these 4 names, acute, obtuse, right, or equiangular, all relate to naming triangles based upon their angle measurements. In acute, just like an acute angle is less than 90 degrees, an acute triangle has all its angles less than 90 degrees. Okay, so that would look like, and maybe like that. Okay, all 3 of these angles are less than 90 degrees. So all angles less than 90 degrees, we have an acute triangle. Obtuse, we have one angle greater. There's a greater than 90 degrees. The other 2 will be less. Okay, so there's my greater. These are less. Okay, and so you have one angle greater than 90 degrees. The other 2 will have to be less than 90 degrees. And so, what do we know about this? That this is called an obtuse. Now, why would the other 2 have to be less than 90 degrees? Because all triangles, the sum of their angles equal 90 degrees. I should put that in. So this is an obtuse triangle. The next one is a right triangle, and that means, remember, a right angle means 90 degrees. So one, doesn't matter how long these, as long as one of the angles is 90. Okay, and then of course the other angles will have to be less than 90. Okay, I really should mark it that way. I'm just showing you. Okay, so let's make sure we understand one more time here. This is the angle that matters to label it a right triangle. One angle is equal to 90 degrees. This is the angle that counts to label it obtuse. And in this one, you're looking at all 3, making sure all 3 are less than 90 degrees in the acute. triangle. Now let's go to the next page to talk about equiangular. Okay, when all angles are equal, the triangle would look like this, and it's called an equiangular triangle. By the way, what would the measurement of all these angles equal? Well, if a whole triangle, the sum of the angles equal 180, if I divide that by 3, because I have 3 angles in a triangle, each angle must equal 60 degrees. All right, now triangles can be classified according to angles, but they can also be classified according to sides. So let's look at the next grouping. And now we're going to be looking at these 3. So notice whether it's equiangular or equilateral, lateral means side, so it's either equal angles or equal sides. Well, equilateral means all 3 sides have the same length. Right? And an equilateral triangle will also be equiangular. So if this is 1 inch here, 1 inch here, 1 inch here, equal length on all 3 sides, this was going to be equilateral triangle. The next kind would be where 2 of the sides would be equal. Let's say this is 1 1/2, 1 1/2, and 1. Okay, when 2 sides are equal, this is called isosceles. Say that again with me. Isosceles triangle. Now the next one would be where all 3 sides have different lengths. Here would be an example, and we call that scaling. Again, pronounce it with me, scaling. Scaling triangle. Different lengths. Okay, here are some triangle rules. If sides are equal in 2 different triangles, if the length of the sides are equal, then the opposite. Okay, if 2 sides are equal, there we go, then the opposite angles are equal. Let me show you what I mean. First off, what do I mean by opposite? Okay, if I have a side here, the length here, if that is the side, this is the opposite angle. If this is the side, that's the opposite angle measurement. Okay, now the rule says if I have a length there and a length there, if they're equal, okay, they're not equal. Let's try that again. Okay, I was thinking in 2 different diagrams. Okay, I'm trying to think how I want to draw this so it's real clear to you. Okay, there's always 3 angles in a triangle, right? Okay, so if this side is equal to this side, then this angle is equal to this angle. Now notice the third side's not equal, and that angle is also not equal. That's a nice big angle, right? All right, so that's what that rule says. The opposite is also true. If I draw a triangle and I have a certain kind of angle there, and on the other side, I've got the same angle, Okay, so that equals that. They're both the same. Then if I were to finish out that triangle, then I know that that side is equal to that side. If the two sides are equal, their angles, opposite angles are equal. If two angles are equal, their opposite sides are equal. Now there's one more idea here in this section. Well, first off, also on the previous page, I defined for you similar triangles and congruent triangles. Two similar triangles are when they have the same shape, but not necessarily the same size. That and that are similar triangles, same shape. Okay. But this and this are same size, and are congruent. They have the same shape and the same size. So these are congruent. That means each side, this side here would be equal to this side here. This side here would be equal to this side here. This side here would be equal to that side there. Same with the angles as it is with the sides. All three angles would be also equal. Okay, you could think about that, and you already know that from the rules I gave you above. Now, these are similar. These are congruent. Now, I want to give you a few rules about congruent triangles. How would I know that one triangle, triangle A, is congruent to triangle B? How would I know? There's three ways I would know. If all three sides are equal, if this side is equal to this side, right? And this side is equal to this side, and this side is equal to this side. If all three sides are equal, then they're going to be congruent. And this is called the side-side-side hypothesis, or the side-side-side theorem. Okay. Side-side-side. Now, what would be another way? I would also know these two triangles are congruent. Congruent's the same as the word equal, except it's for a two-dimensional figure rather than a quantity. Okay, measurements can be equal. The measurements of a length can be equal. The measurements of an angle can be equal. But a shape cannot be equal unless it's the very same triangle. But they are called congruent if they have the same measurements. Okay, so another way, if I knew that ASA, that means angle, side, angle. That means that the side is between the two angles. That the order is important. So let's say that side and this angle and this angle. If that side is equal to the one on the left, and that angle are equal, then we know that the triangles are congruent. The side must be between the two angles. You see that? Okay. Now the third one is going to be SAS. These are all theorems. They can be proved. Okay. But you do that more in a geometry class later on. But right now we're just asking you to know them. 3 congruent, triangle congruent rules. Okay, now let me go back and get the last one, SAS. This means the angle is between two sides. So how I would look at that? Instead, I would have one side equal, another side equal, this side and this side, let's say, and the angle between them equal. If I knew those three things were equal, then I would know that the triangles were congruent. All right, so we have pictures on page 318 for each of these. Looking at the picture on the left with the light blue triangles, I see that two sides are equal, 3 centimeters and 3 centimeters on the top triangle, on the bottom triangle, 2.5 centimeters on the top triangle and the bottom triangle, and the bottom side is also equal, 4 centimeters on both of them. So they are congruent because of SSS, side, side, side. In the middle, the green triangles, I have two angles are congruent, and the side between them, 50 degrees, 1 inch, 70 degrees on the top triangle, and 50 degrees, 1 inch, 70 degrees on the bottom. So they are ASA, angle, side, angle, with the side between them. So these two triangles are congruent. How about the last one? Well, I have two sides that are congruent and the angle between them. So side, angle, side is the reason that those two triangles are congruent. Now let me take a look and see that you can be able to do this whole section. Okay, I have decided not to go into the next section that I thought I'd be able to cover, because this is really quite a lot of new ideas in this triangle section. So we will not cover perimeter this time. Your homework, and this is of course for lesson 29A. Okay, so you should have homework all gathered together so that I could collect it and check it if I need to for 29A, 29B, 30A, 30B, all the assignments all the way back, and just like you were doing when you were in class. It's no different. Our rules, our expectations are no different at all. You're going to do 1 through 24 all. This is lesson 8.16. And then you're going to do the sharpening skills 1 through 30 all. Make sure if you cannot define that section on definitions, you go back and you find all those definitions. By the way, I did not tell you, but if we're saying two triangles are congruent, we would say triangle A is congruent, that squiggly line above an equal sign, to triangle B. Okay, this is a triangle sign. Okay, so this is the symbol for congruence. We've covered that before, but not with regard to triangles. All right, so that should be enough for you. Remember, like always, what's the rule? If you have any questions, don't wait 3 weeks to ask. You text me. 505, you should have this. It's on every assignment here, on every tape. 505-301-1357. If you have any questions, do them, text me each week if you do not understand. Okay, have a blessed day.